Hey, algebra students, in this lesson, we are going to be using the product property of radicals to simplify radical expressions. Now, what is a radical expression? Well, it's an expression that has a square root symbol in it. At least that's the simplified version we're going with for right now. So what we're going to be doing is taking the square roots of numbers that we can, and we'll be leaving alone numbers that we can't. And here's the thing. In this lesson, we are going to start requiring something called simplified radical form, which means that you are going to simplify an expression the furthest you possibly can, and it's still going to have a square root symbol in it. What we're really doing is we're looking for perfect square numbers. So an example of a perfect square number would be like 25. The square root of 25 is 5. We can take the square root of 25 and simplify it and make it a non-square root number, 5. Okay? Same thing for 9. 9, the square root of 9 is 3. Same thing for 36. The square root of 36 is 6. Square root of 16 is 4. Square root of 64 is 8, and so on. There's many different perfect square numbers that we're used to dealing with on an everyday basis. Now what we're doing is we're looking for those perfect square factors in larger numbers, and we're going to end up taking the square root of those perfect square factors. We're going to be using this product property of radicals as we do this. And what this says is that if we have two square roots of numbers multiplied by each other, this product equals the square root of both numbers multiplied together. More importantly is the one over here on the right. It's just the converse of this. If we have AB, the square root of AB, that's the same as the square root of A times the square root of B. Now, how does that play out? Well, let's actually take a look at this in a real problem. Here we're going to have letter A, and we're going to take the square root of 75. Okay, the square root of 75 is the same as the square root of, can I break this down into any perfect square numbers? Well, 25 is a perfect square number, and 25 times 3 is 75. But we're not talking about 75. We're talking about the square root of 75. So instead of 25 times 3, we're actually going to do the square root of 25 times the square root of 3. You see how that's the exact same thing as the square root of 75, according to our product property of radicals? One of these two square roots I can simplify. Square root of 25 just becomes 5. This is going to be 5 times the square root of 3. That's my answer in simplified radical form. I don't have to put anything in decimals. I'm not going to punch square root of 3 into a calculator. In fact, you're not even going to be allowed to use calculators for problems like this, because I need to see that you can actually solve this without a calculator and get this result. So again, we're on the hunt for perfect square numbers. What about the square root of 63? Well, 63 is 9 times 7. That means the square root of 63 is the square root of 9 times the square root of 7. One of those numbers can be simplified by its square root. The square root of 9 is just 3, so the answer here is 3 times the square root of 7. Hey, let's just go back and check these and make sure we answer them correctly. 5 square root of 3 and 3 square root of 7. Just so you know, a common mistake people make when they simplify this, instead of the square root of 9 being 3, they just write 9 times the square root of 7 and forget to actually evaluate the square root. Remember, to get rid of the square root symbol, you actually do have to evaluate the square root. All right, letter C. The square root of 363 using prime factorization. Okay, so prime factorization means that I'm taking 363 and I am breaking it down 100% into its prime numbers. Well, let's see. 363 is going to be a number that divides by 3. And if I think about that, 363 is going to turn into, is it going to be 121 times 3? Here, let me just move this over here. Yes, 3 times 121 is 363. That's pretty obvious by just inspecting the number. All right, 121, is that divisible by anything? I'm going to get a calculator out just to figure this out. 121 divided by 3. Nope. I would have known that if I would have known the rules for dividing by 3. When I add the digits together, they don't add up to something divisible by 3. Let's try divided by 7. Nope. Let's try divided by 9. 11. Oh, look at that. 121 is actually 11 times 11. Well, that's handy. So that means that 121 becomes 11 times 11. Okay, now that means that my prime factorization for 363 is 3 times 11 times 11. Now here's the thing. The square root of 363 is the square root of 3. Here, let me just grab the square root symbol. The square root of 3 times the square root of 11 times the square root of 11. And anytime I have a square root times a square root, like the square root of 11 times the square root of 11, well, let's think about that for a second. The square root of 11 is the number you have to multiply by itself to make 11. I'm multiplying that by the number you have to multiply by itself to make 11. The square root of 11 times the square root of 11 is just 11. Another way to think about that is the square root of 11 times the square root of 11 is the square root of 121. Well, the square root of 121 is perfectly evaluatable. It's 11. So this actually becomes, I have to put my number that's not a square root first. 11 times the square root of 3 is the answer for letter C. And the way that I figured that out is I took the prime factorization. I realized I was multiplying 11 by itself twice. The square root of 11 times the square root of 11 is just 11. And then the square root of 3 was left over, so I had to bring over the square root of 3. All right, letter D. Simplify that square root of a million using powers of 10. Well, this is going to be the same as the square root of 100 times the square root of 100 times the square root of 100, right? Because the square root of 100 times the square root of 100, this is going to have 4 zeros times the square root of 100. It adds on 2 more, so 6 total zeros. 1, 2, 3, 4, 5, 6. This is the square root of a million. Let's see how this is just, the square root of 100 is 10. So this is 10 times 10 times 10. And 10 times 10 times 10 is 1,000. That's how you would do that. Letter E. All right, now we're going to get some variables involved. It's going to be the square root of 90 times b squared e to the fourth. Square root of 90, well, 90 is going to be 9 times 10. So the square root of 9 times the square root of 10 times the square root of b squared, okay? Because remember, everything's got a square root over it, times the square root of c to the fourth. Well, I could evaluate some of these square roots. Not all of them, but some of them. For example, square root of 9 is 3. Can't do anything with the square root of 10, and 10 doesn't break down into any perfect square factors. 2 is not a perfect square, 5 is not a perfect square. But the square root of b squared is just b, and the square root of c to the fourth is c squared. How do I know that? Well, if I took c squared times itself, I get c to the fourth again. So that's my answer. 3 square root of 10 bc squared. Hey, let me just check my last few answers, make sure I got these right. There's 11 square root of 3. Did I lose my answer here? I did, but I had, oh, there it is, 11 square root of 3. I just wasn't looking at the 11. I should move that over a little bit so it lines up. Okay, let's see. This one was 1,000, and now this one is 3bc squared square root of 10. I noticed that they put the square root at the very end, so let me just move that over. 3bc squared square root of 10. Okay, let's see, this is going to be letter F. Let me just go back and change this. This should be letter E. All right, in letter F, we have the square root of 25 x cubed y to the 7th. This is a little blurry, but it's x cubed y to the 7th. Well, I could just do the square root of 25. That becomes 5. Square root of x cubed is the same thing as the square root of x squared times the square root of x. Why would I do that? Let's just take a look at what this looks like when I'm done. There's the square root of x squared times the square root of x. Well, I could do the square root of x squared, right? I do the square root of 25. I do the square root of x squared. I can't do the square root of x, and I can't do the square root of x cubed. But by breaking this down, I get one square root that I can evaluate. And then times the square root of y squared times the square root of y. Now, does this make sense that this is the square root of x cubed? This, I messed up. This is to the 6th. So square root of y to the 6th times the square root of y, this is y to the 7th. And when I multiply this back together, like if I were to put this back in its original form here, This becomes the square root of 25 x cubed y to the 7th. Now let's evaluate what we can. Again, square root of 25 is just 5. Square root of x squared is x. Square root of, I'm going to jump to this one. Square root of y to the 6th is y to the 3rd. Okay. But now I still have the square root of x and the square root of y unevaluated. So it's going to be square root of x, square root of y. And actually, I can multiply those back together. Y cubed, and then the square root of xy. Okay. And I'm just going to put parentheses around this to show that these are both within that square root. Let's make sure I did that right. Bam, 5x y cubed square root of xy when I simplify everything that can be simplified. Finally, letter G. Find the length of one side of a square room with an area of 80 square meters. Okay, so let's see. 80 can be simplified to make it 4 times 20. So this would be the same as the square root of 4 times the square root of 20. 20 can be simplified, though. By the way, this is the square root of 80. 20 can be simplified to get a perfect square factor out too, because 20 is the square root of 4 times the square root of 5. That tells me that originally this could have been just broken down into the square root of 16 times the square root of 5, and then I could have taken the square root of 16. But either way works. So square root of 4 is 2. Square root of 4 is 2. 2 times 2 times the square root of 5. This becomes 4 square root of 5. Make sure I got the right answer here. 4 square root of 5 meters. And that is how you simplify radical expressions using the product property of radicals. You are now ready to do the assignment for next time.